This is the lecture for chapter 10, which is vectors. And this week we're going to talk about vectors. We're going to talk about polar and rectangular coordinates of vectors. Now, what is a vector first? A vector is quantity with magnitude and direction. Okay? So we have vector looks something like that. I'm going to show you the graphical representation of vector first, so you can see it. Like all the forces, they're represented with vectors. So you have start point, and you have like this. So this is a vector, right? Now, the vector has magnitude, which is how long is this from this point, from the start to the end point. So this is the magnitude. I'm going to use m. And direction is pretty much what is the angle with the x-axis. So this is the direction. Okay, two vectors are equals if they have the same magnitude and the same direction. Now, so if you remember last time, we talked about rectangular and polar coordinates form, right? So vectors also, they're represented the same way like point, like numbers, they're represented in those two different forms. So you can have polar or you can have rectangular coordinates, okay? So you have polar and rectangular. So rectangular form of vector, we're using, these are the A and B, it's rectangular, and the polar is r and theta, and angle theta. Okay, so we're gonna go more in details about that. Okay, so here we have if the vector, so this is the notation of vector. If you have v with a little arrow in the top, it's a vector v, which is drawn in standard position. So standard position is when the beginning of the vector is at 0, 0. So that's what it's called standard position. So you have a vector somewhere, doesn't matter where is the vector. Let's say this is my vector from here to here, right? That's my vector. If I want to put it in standard position, I'm going to take it and I'm going to translate it to start from the beginning here. It's going to be in the parallel, the same direction, and it's going to have the same length. So you measure the length from the beginning to the end, it's going to be the same. So this is standard position. Okay? Okay, it's the same vector, but this here is in the standard position. You can move it wherever you want to move. That's the same vector. You can just translate it in a parallel line, which means the same direction, and the length is going to be the same. Okay, so this is the standard position vector, and this is how you write the rectangular form. So it's going to be pretty much the coordinates of this point are going to be A and B, right? Because start from the origin, from 0, 0. Now, what are A and B? These are the formulas for A and B. We have the same formula for polar and rectangular coordinate when we talked about last time, right? So, but instead of magnitude, so this is called magnitude of the vector. We talk about r cosine theta, right? The same idea. R cosine, and this is going to be r sine. And sine and cosine, again, the functions from pre-calculus, okay? Where theta is the direction, so that's the angle. So this is theta, this is the angle here with the x coordinate, this is the angle theta. Okay? And this here, the length from here to here, I'm going to put it here, is the magnitude of the vector v. okay? So pretty much we have the same formulas we talked about last week, right? We talked about polar and rectangular coordinates. So the formulas are absolutely the same, okay? Any questions so far before I do the example? No? Okay. So here we have one example, and probably going to make more examples. We have example where we have given a vector which is in rectangular form, which is 5 and 3. And you have to change it to components, to polar. So you have, so these are A and B. So finding so A and B are the coordinates of this point here, right? So if I want to find the magnitude of the vector, we're going to take square root of A squared plus B squared, and that's going to give me square root of 34. Okay? And then if I want to find the angle, I'm going to use, see, the magnitude is what we just did. So this is the solution. The magnitude is the one we just did, okay? The square root of 34. Magnitude is called like this, magnitude of the vector, which is how long is the vector. Step 2, we're going to find the direction, which means finding the angle. So here we're going to find the angle, it's tangent inverse. And this is the formula we used last time, if you remember. The same formula. So this is the angle theta. And then you're going to write it A cosine, so using this formula, A cosine and A sine, this one.
I'm sorry, but what exactly are we solving for?
Okay, this is what you're solving. We're changing the form of the vector. Okay, we have it
Changing the what? I'm sorry?
Polar to rectangular, rectangular to polar. So we're changing, if you have polar coordinates, you're changing it to rectangular. If you have rectangular, you're changing it to polar. Okay, so in this case, we have given a rectangular, which is the, see, if you have it given with these brackets, like this one, if you have vector like this is rectangular forms. And if you have theta and this one, it's polar. So these are the two different ways of representing polar and rectangular. Do you guys remember that? Do you understand this now, or you can do another example to see?
This is all
Let's do
new
another
to
example,
me.
please.
Yes, you can do another one. So let's do another one. Okay, so here we have, okay, so just the notation is different. Probably that's what is confusing, because the notation, it's, you see that Rx, Ry, which is A and B. Okay, so I'm gonna do another example. So I'm gonna insert another slide, and we're gonna do example. So I'm gonna pick up two. So right now we're doing from rectangular to polar. And I think I have a slide with everything, with everything together. Okay, so let's make up example. I'm gonna make another one. So we have, let's pick, so give me two numbers.
3 and 7.
3 and 7. Okay. This is a rectangular form of the vector, right? Okay, now remember, it's similar like what you did with complex numbers. Okay, remember you have polar and rectangular, right? Now looking at 3 and 7, which quadrant is the end point of my vector?
7.
Which
One.
quadrant? 1, 2, or 3? Or 4?
Right.
1, right? Because x is
One.
positive and y is positive, right? So this is my, yes. So this is my, see here, I was talking about standard position, right? So the standard position is going to be in first quadrant, right? So I'm going to draw a picture so you can see where exactly is my vector. So the vector is going to start at 0, 0, and it's going to end, the end point is going to be at 3. Let's say this is 3, and this is 7. So this is the end point. And this is my vector. Everybody see that? Yes? So now this vector, I can represent it with 3 and 7, which is the rectangular representation of this vector. Okay? And I can also, it's the same like complex numbers, remember?
So,
But here,
so the equation is for the rate of change, or
the equation is for, no, it's for polar coordinates. You have rectangular, you have polar. So one way of representing the vector is the point 3 and 7, right? The coordinates are 3 and 7, yes? Another way to represent this vector is using here this distance. How long is this? Which is called magnitude of the vector. And last week we have it like r and theta, right? Yes? The angle. Do you guys remember this from last week? Yes. So we have one way is 3 and 7, which is the rectangular. Another way is r and theta with polar. But here they're not using r because they're using r in the other one for complex numbers. Here they're using like absolute value of the vector, which is called the magnitude, which is the same. So whatever you see magnitude of the vector, which is absolute value of v of the vector, is the same like the radius. Okay, the r, the distance. Okay, so it's the same. They just use different notation because here we're talking about vector, which is a representation of different forces in nature, right? You have the gravity and you have all different forces, and they are usually represented with vectors. Okay, why they are represented with vectors? Because they have a direction, whatever the force is pulling or pushing. Okay, and they have magnitude. They have what is the force. Is the force strong or depend how long is that line? Okay, everybody understand it so far? So what you're doing here right now, we're changing a rectangular, which is the one we have here. The numbers you pick 3 and 7. This is the rectangular form. And you want to change it to polar. Okay? Now, in polar, it's going to look different. I'm going to write the polar here. It's going to be like the magnitude of the vector. So this is the notation for the how long is the vector, right? The force, how long is the force? And then the angle theta. Okay, so I have to find the angle and I have to find the length. So finding the first one, finding the magnitude. So this here is polar. Okay, now how I'm going to find the polar? I'm going to use the absolute value, the magnitude, or the r, the distance is going to be square root of. Now here we have this, if this is A and this is B, I'm just going to write it as a formula. It's going to be A squared plus B squared, right? That's the formula, or you can use Pythagorean theorem here. And it's going to be square root of 3 squared is 9, plus 7 squared is 49, and it's going to be square root of 58, right? So that's my magnitude. So in polar coordinates, I'm going to have square root of 58. And then I need to find the angle And I'm going to use the angle using the same formula we did last time. And this is your formula. Tangent, see over here, tangent inverse of, now which one was A? B over A. So it's going to be B over A. So we're going to put theta okay, so this is the formula you're using, and I'm going to use the calculator to find it. So it's going to be that's what I put in the calculator, tangent inverse B is 7 and A is 3, right? See, it's the same what I have here, see? So this is, they have square root over here, you see? Square root of first square plus second square give me the magnitude. It's exactly what we have here, right? And the other one is finding here. And this is what they have in the calculator. Okay? And from the calculator, they get this angle. So I'm going to show you right now how to do the angle. And let me show you. So I'm going to plug it in. Where's my symbol up? Okay, so I need to put tangent inverse. So I'm just going to type tan. I'm going to put -1 exponent, which is tangent inverse. And then I'm going to put, what was that, 3 over 7? Yeah, 7 over 3. Okay, and then because it's in first quadrant, it's going to be the same. So it's 66.8 degree. Oops. So we're going to get 66. Okay, 66.8 degree. Okay, the first one here is radians. So let me explain the solution. See here, if you have arctan is the same like tangent inverse. This is radians. And this is degree. We're using degree, okay? So just keep in mind we're going to use degree. And then whatever you get the calculator, that's your angle. So my polar coordinates is going to be square root of 58, and you're going to put angle 66.8 degree. Okay, that's it. So here
So that's the final solution for all that?
Yeah, so we found this is my rectangular and this is my polar. So they give me rectangular, we found the polar. Okay? Now, if they give me the polar and I need to find the rectangular, then we're going to use the other formula. We're going to see this one. See, this is the so this is the magnitude, and this is cosine of the angle, and this is the magnitude sine of the angle. So this is how you do that. You got it? So here they just go it back and forward. They're just doing it back and forward from polar to rectangular, rectangular to polar. Okay? So that's all what that means. So using the same formulas like last week, where we talk about complex numbers in polar and rectangular, the same way you're talking about vectors in polar and rectangulars, the same formulas. So we can transfer the different forms. Yes.
Okay.
Yeah? Okay. So now, why you need two forms? Because some things are easy with one form, with rectangular, some things are easy with polar form. That's why. Okay? And we're going to look at the addition of vectors. So we're going to talk about adding vectors, subtracting vectors. So all these operations with vectors, we're going to use in rectangular. So when you have the vectors in rectangular form, it's easier to add and subtract them. And why you have to add and subtract them? Because in nature we have a lot of forces and we have to combine them sometimes, right? To see where the reaction is, what's going to happen, right? You have object with a lot of forces in different ways, and if you want to find ways the result, the reaction, what's going to happen with that, you need to use the formula. Yes, that's correct, Marcel. That's the formula. Yes. So here, what's happened? If you add, you're just gonna think about complex number. You have real and imaginary component, right? So the vectors in rectangular form, so this is a rectangular form, right? So when you add, so when you do addition, the vectors have to be in rectangular form. Okay? If they're in polar, you need to change them. You need to go to rectangular form. Okay? And how you add them? You add x component and y component, because rectangular form looks like this, a and b, right? Here they have it x, because a and b, it's easy to see the formula. See, if I have vector u and vector v, two vectors. So instead of using a and b, because it's kind of confusing because they're two different vectors, we're gonna use like ux and uv, which means x component and y component for that vector u. And the same way you have x component and y component for the vector v. Okay? And how you add them? So the operation adding is here. You add in the x component and you add in the y component. And that's how you get the result vector, okay? And here you have example. So the example given is, we have one vector is 3 and negative 2, and the other one is negative 4 and 3. So we add in, this is the x component, and this is the y component for u, so it's going to be ux and uy, and this is for v, x and y, right? And you can just use x and y, so it's not, okay? And then you're going to add, you're adding x component with x component. So that's how you get this. 3 plus negative 4 is negative 1, right? And then you're going to add the y component. So you're adding negative 2. You're adding it with 3. So you're doing negative 2 plus 3. So you have that comma here separate the two components. And that's how you get the 1. Okay, so the resultant vector is going to be negative 1 and 2. Everybody understanding this? Yes? Getting better? Okay, I have thumbs up. Okay, so let's see what else we have. So here we have addition of two vectors which are given in polar, right? So when the vectors are given in polar form, so this is polar, right? What you guys think we're gonna do? We need to change it to rectangular, okay? So you have to convert them to rectangular. And after you convert them, you're gonna change it, you're gonna add it, and then you're gonna convert back. So these are the steps. So the rule is, if you have vector given in polar, you're gonna change, you have to change it to rectangular and then go back to polar. Okay? So how you do that? You're using the formulas again. And I have a formula sheet for you. I'm gonna put that in the formula sheet is I'm gonna add it to the Blackboard. Okay, so technically what you have is, you have two vectors in polar. You're gonna change it to rectangular. You're gonna add them. Add x component with the x component, y component with the y component, and then transfer it back, convert it back to polar. Okay? So the idea behind all this is using the formulas, and these are the formulas we have in the Blackboard. So when you go to Blackboard, and then when you go to lecture material, you're going to see the formula sheet. Okay? So using that formula sheet, this is the formula sheet, we have the formulas from polar to rectangular, rectangular to polar. Okay? So it's the same idea we did with imaginary numbers. Yes? Question?
So when you're converting from rectangular to polar, and you do the tan -1, say if your one of your rectangular numbers have a negative, does that negative transfer down? Does that negative crosses over?
No,
to
just
the
keep it.
fraction?
No, you keep it negative in here when you put it b over a. You keep it with negative. Yeah, I'm gonna do example with negative so you can see. So when you go from See, this is what you have to keep in mind. So let me explain here in the formula sheet. So if you want to go from polar to rectangular, these are the formulas you're using. If you want to go rectangular to polar, these are the formulas you're using. Okay? And you always add two vectors, component by component, by adding x component and y component. This is how you add them. You add x and x, and you add y and y. They have to be always in a rectangular form. Okay? So that's what you need to remember. Okay? So these are the formulas. Now, let's go ahead and do example so we can see how, just to practice that one more time. Here we have, just finish the PowerPoint, how you add vectors with in visual. So you add in them when you do tip to tail method. So if you have vector u and vector v, so these are like in the graph, you have the vector u, the vector v, and then when you add them, you have to position them, the tip of the first is going to be the same like the tail of the second one. So they kind of, the first vector stop here, and then the second vector starts here, and then the result vector is going to be from the beginning of the first to the end of the second. Okay? So you have vector u plus vector v, you have to position them like this, and then this is the result. Okay? We're not going to have more of this, but just to have a visual what that means. Okay? So that's one method. And applications in vectors, we have forces, current, medium, and all that. We're going to talk about acceleration. I mean, there are a lot of application in different places. And you have here another, it's kind of physics. You know, physics, they use in vectors. Okay? So I'm going to pause the recording and we're going to do example. So let's pick example. I'm going to pick example where you're going to add vectors, and I'm going to include it right after this. And you're going to do few examples, as many as you need, okay? So let's insert a slide. So let's pick two numbers. So we did example with first quadrant, so I'm going to pick numbers which are going to be in another quadrant. So let's pick a vector in rectangular. And you're going to go to polar. So pick a vector. Give me two numbers, not first quadrant. That means they're not positive. Pick negative numbers. One negative or two negative.
Negative
numbers.
7 and 2.
Is that from the quiz? I hope no.
No, I just threw it out there.
Just make it. Okay. Negative 7 and 2. So let's pick those two numbers. Okay. So this is in rectangular, right? So we're going to go to polar. So first I need to find the magnitude of the vector v, right? Which is the square root of negative 7 square plus 2 square. Okay. And then what is that? So I have 49. This is 49. And this is 4. When you add 49 plus 4 is 53, right? So it's going to be square root of 53. Yes? So this is the magnitude of the vector. Now we need to find that angle theta, which is tangent inverse. And now here we're going to use the formula. But now which quadrant is the vector? Negative x and positive y. That's in the formula sheet. So if you have negative and positive, which quadrant is that?
2.
Quadrant 2, right? Okay. So if you're in quadrant 2, you're going to add 180 degree to the result, right? So we're going to put it like that. Tangent inverse b over a. So that's what you're doing. So if this is
my
a.
question.
That was the question, yes.
Question?
Yes,
Yeah.
yes, I know. I'm just gonna go over it so I can see it. So b over a, so it's gonna be 2 over negative 7. And that's how you're gonna put it in the calculator. And you're gonna add 180 degree. Okay? So in the calculator, I'm gonna do it for you guys. I'm gonna plug it in. So we're gonna put tangent inverse What was that?
Uh,
2 over
negative 7 and 2.
Yeah, 2, 2 over negative 7, right? Just
I
put
think
it
it's
like that. Yeah, it's going to calculate the tangent. It's going to give you, this is the degree. Make sure you get the degree angle. So it's a negative, oops, I was trying to copy that. So it's negative 15.97. And you're gonna, I'm just gonna do it in my calculator in my phone. So we're gonna do negative 15.95 plus 180 degree. Is what you get? 160. So it's gonna be 164.05 degree. Okay?
Mhm.
So this here, the
Question.
tangent is negative 15.97 degree. I'm just gonna write it here to have it. Okay? Any questions?
Yeah, real quick. How do we enter
Yes.
degrees into the calculator?
You don't put the degree symbol. You just add the numbers. See the calculator here? I just get it from here. It depends which calculator you're using. Usually the calculators, if it's like regular calculator, it's set up to degree, and there should be option to change degree to what is called radians.
Now, on the quiz, would you like for us to identify what quadrant it's in? Or like
Yes,
showing the work?
yes,
Okay.
yes. So when you do your work, so this is what you're doing. So this is example when you change rectangular to polar. So this is given, and B is given. You do the calculation, you can just put second quadrant. And then what is your polar? So this is rectangular given. The polar is going to be, you write it square root of 53. Square root of 53 is the magnitude. How long is the vector? And then you're going to put angle 164.05 degree. Okay? Now, if you type it in, you can just put the letter L here, capital L, like this, when you type it in. And then you can just put the degree. You can just press, if you're in Word, in the Word file, you can just, you know how to go to home, and you can just put here, press the, like the square, the same way, the sub. Okay? Any questions so far? So this is how you do rectangular to polar. Now we're going to do another one where you can do polar to rectangular, right? So I'm going to do another example. Everybody okay so far? So let's do it backwards. So now I'm going to give you, so I'm going to have given polar.
The answer that you wrote down is negative 15.95, not 97. I don't know if that matters.
Oh, yes, actually, yes. Thank you. 9.5. Yes, thank you. Absolutely. I don't know why I put 7. Thank you. Yes, I was talking and I just put thank you. Yes, you just keep it the way it is from the calculator. Thank you so much. Yes. Okay. Yeah, that's right. 164. Yeah, when you add it to 5. Yes. Okay. Thank you for that. So now we're going to do polar to rectangular coordinates, and we're going to change it the same way. So let's say I have given polar, which is, let's pick a number, let's say 5, and pick an angle from 0 to 180 degree. Give me a number. From 0 to 180. Obviously between, if the angle is between 0 and 90 is first quadrant, from 90 to 180 it's second quadrant, From 180 to 270 it's third. From 270 to 360 is fourth quadrant. So pick a number. I'm sorry, what'd you say? 75? That's first quadrant. Let's pick another, or I don't know. Pierre said 289. Let's do that. Which quadrant is 289?
Fourth quadrant.
4, because it's bigger than 270. Good job. That's right. So this is fourth quadrant. Yes. So we're in fourth quadrant. How you know? From the angle. Okay? So now here we're going to find rectangular form. Okay? So how are you going to find it? You're going to use the formula sheet. See the formula sheet, polar to rectangular, this one here, right? So it's going to be the magnitude times cosine is my first coordinate. Oh, sorry, here. So it's going to be, the magnitude is 5. And then you're going to do cosine of 289 degree. Comma, this is the x coordinate, the x component of the vector. And then the y is going to be 5 sine function of 289 degree. Okay? So that's what you need. You need to put this in the calculator and you need to put this in the calculator. Okay? So let me show you how to do that.
May
So-
I ask a quick question?
Yes. Go ahead.
What is the cosine and sine? I don't know what those are.
Okay, those two are functions from pre-calculus. So sine and cosine and tangent, they're functions from pre-calculus functions. So sine function, it's a function which give me, if you look at right triangle, there are different approaches to do that. You can represent the sine and cosine and tangent and cotangent. They're more trig function is called. Those functions you can have, you can represent them with a right triangle or with a unit circle. And I can show you right triangle in a minute. Let me calculate this and I'll explain the sine and cosine functions. Okay, just a second.
I'm sorry, but where did you get that 5 from?
Is the magnet, this number given here? How long is the vector? It's given. Okay, so we're gonna put 5 cosine of 289, right? Just put it like that. See, it's automatically symbol up is set up for degree. It gives you the degree. Okay, so you don't need to put the degree symbol there. Okay, so here let's round 2 decimals, so it's going to be 1.63. Okay, 1.63. And then you're going to do the other one, sine. So let's do the sine function. So I'm just going to change cosine to sine. Everything stayed the same. And should be a negative because you're in fourth quadrant, right? So it's going to be negative 4 point. Yes, cosine give you the x, sine give you the y coordinate, yes. So it's a negative 5.73. Oops. 4.73. So these are the x coordinate and the y coordinate for my rectangular form of the vector. So the vector is going to have coordinate, this is how you write it. 1.63, comma, negative 4.73. Okay? So this is my x component and this is my y component of the vector. And obviously if x is positive and y is negative, we're in fourth quadrant. So always when you get your answer, you can double check, are you in the right quadrant? So it doesn't matter if it's in polar or rectangular, you can say which quadrant is the vector. So make sure in both forms, you're in the same quadrant. Okay? So any questions about this? I can explain the trig functions if you want me to go over it, or you okay with just plug it in sine and cosine in the calculator, or you want me to explain?
I'm good. For the sake of class, I'll go and I'll research it on my own. That way you can keep moving forward with your class.
Okay, no problem. So, I mean, pretty much this is what we have. We have to change polar to rectangular, rectangular to polar. And we're doing that because when you have to add two vectors, they have to be in rectangular form. When you add the same way, they have to be in rectangular form. Okay? So pretty much this is the lecture for today. You have vectors. You can change it from polar to rectangular using the formula, and rectangular to polar both ways. And also you can add and subtract vectors. When you add or subtract vectors, it's easier to have the vectors. I mean, you have to have the vectors in rectangular form. Okay, so that's the lecture for this week.